All right. So we will talk about 7.1 and 7.2. I got a couple questions on 7.1 that a lot of students are having trouble with. And then 7.2, I need to point out something first, because 7.2, when you do your online homework for 7.2, it's like a fill in the blank, you know, how you prove your identity. But in your finals, it is not going to be fill in the blanks like what you did in your online homework. It's exactly going to be like you have to prove from left to right, right to left, or something else like that. So just want to point out to you guys that it's a bit different, and there are some rules about that. So make sure you follow the rules. And if you did not follow these rules, you might end up getting a 0 in the test. And then if you have time, we'll talk about 7.3, how you solve trigonometric equations. Okay. So so let me share something important here. The first thing I want to point out here is your finals. Your finals will cover chapter 6, 7, 8, and 11. So we are in chapter 7 here, which is the killing chapter that I mentioned earlier on. And then 8 and then 11. That's it. So we only left. So your finals will consist of 6, 7, 8, 11. Please write this down in your calendar or in your cell phone, or remind yourself your final is on Monday, the 14th. I will give it to you at noon. And it'll be due on Tuesday, December 15th at noon. So you have, again, 24 hours to do your finals. So make sure you guys put this in your cell phone to remind yourself that this is your finals date. So now we will talk about this chapter 7.1 here. So someone asked me about doing question number 15 on 7.1. So so let's talk about that one. So some of those, so there are a lot of ways for us to prove some identity. So I will show you some of the ways in my in my notes here. But one of the famous way is you can factor it. Okay, and definitely you have to use your identities. Okay, your identities is a must to use. So number 15 is where a lot of students having difficulties to do this. And the reason why is because factoring. Okay, so make sure you guys know how to factor here. So how do we do question number 15 in this case? Ryan, you got any questions for me? Ryan? It's quite. So 7.1 and 7.2 is fine. Yep, no matter, it's fine. If you have any questions, just type. So this is 7.1 on question 15. So you have to factor this. And how do you factor this? If you doesn't like this sine and cosine or secant or whatever you have, you can change this to 1 minus 2x squared plus x4. This is very similar to that, because I just changed my sine x to become x here. So so you need to know how to factor this. If you know how to factor this, then yes, then you know how to factor that fellow. It's the same thing. So 1 is 1 and 1. X4 is x squared and x squared. And because we need to get a negative 2, this 2 will be both negative. Now, if you want to see if your factor is correct, you just FOIL this one out. And the foiling for this, you will get 1. And then you got a negative x squared minus x squared, which give me negative 2x squared. And then this will give me a x4. So this is the correct factor for this. Now we go back to question 15. How do you factor this? So this factor is actually the same as what you have here, but we change your x to become sine x. So you will get 1 minus sine square x and 1 minus sine square x. So this is the factor for question number 15. However, we are not done yet, because we can still use identity here. This has a square on it, and the only identity that has squares involved is Pythagorean identity. And what the famous Pythagorean identity that we have in this case is sine squared plus cosine squared equals to 1. And as I told you in the last Zoom meeting, that this identity can be switched around like equation, like, you know, you can move things around. So you can make this Pythagorean identity as 1 minus sine squared by moving the sine square over there. So what we have here is 1 minus sine square, because once you move the sine square to the other side, it's 1 minus sine square. So what you left here is cosine square. So this, if you use your Pythagorean identity, this will be actually is cosine square x and cosine square x. So this gives me cosine square. This is the same thing, cosine square. And cosine square x times cosine square x will give you cosine 4x. So this is your answer for question number 15. Okay. So what you need to do is factor and then use your Pythagorean identity to do this. And again, I told you before in the finals, you do not use this. Usually I will say, I want you to prove this equals to cosine 4x. So you have to prove it like this. Okay. The next question that I have is 39 in this section. So 39 is 2 over tangent square x plus 1. So this is question 39 here. So chat room. Yeah, I'll do 17 ways later on. Give me. So what we need to do in this case is because again we have a tangent square here, we might need to use the Pythagorean identity again. So does anyone know what is? Let me see. I think this. We'll see what happens. Maybe we can do something else with it. So if you look at this, we can change this to become a tangent. So how do we change the tangent? Tangent is sine over cosine is tangent. So that means this we have to over by cosine squared. So what we have using Pythagorean identity here is sine over cosine is tangent square x. Cosine over cosine is plus 1. And then 1 over cosine is secant square x. Okay. So this is another Pythagorean identity. So that means that we can use this Pythagorean identity for him. So tangent square x plus 1 is actually 2 over by secant square x. Okay. And then what we do next here is this is 2 times 1 over secant square x. Now, as you know that secant is the reciprocal of cosine. So this is already 1 over. So this answer will be 2 cosine square x. So your answer for question number 39 is 2 cosine square x. So this we use Pythagorean identity to get in. And then because this is 1 over secant is the same thing as cosine square x. So this is 2 cosine square x in this case for question 39. 17 is the next one. Grace, yeah, Grace, ask me any questions you have on this section. This is 5 sine square x minus 8 sine x minus 4. And the question already asks you to factor. So I don't like to write this in sine, so I just change it all in x. So this is 5x squared minus 8x minus 4. And you need to factor this. So go ahead, factor this one out. Everyone factor it. private message me what you get when you factor here. Yep. I want you to factor this and then private message me what you have once you finish factor. You should know how to factor this. It's not that difficult. So yeah, I would recommend that to change to this first and try to solve this. If you're able to factor this, then you should be able to factor that. Yep, factor this. And if he doesn't know how to factor, then say goodbye. You should never know how to factor all this. This is not. Yep, that is good. That is correct. So it's 5x plus 2 and x minus 2. So this will give me negative 8x if I fold it up. So now we just need to change this back to what we have by changing all your x to become sine x. So this will become 5 sine x plus 2 and sine x minus 2. And that's your answer for number 17. Because there's no square here. So if they don't have any square, we cannot use Pythagorean identity. And because they're all in terms of sine, if you have like secant or cosecant or cotangent, then you flip it, you know. So this is your answer in this case. So 5 sine x minus plus 2. And then sine x minus 2. This should be your answer in this case. Grace, are you okay? Anyone have any questions for me? Anyone? Anyone have any questions for me? 35? Okay. Again, class, in the test, usually I want you to prove. So make sure you... Oh, this one you use trigonometric. Sine pi over 2 minus u. This one you use your identity. This is one of the identity that we have here. Remember your identity? This is identity. So which one is this going to work for this one, Ryan? Which one should we pick? 1, 2, 3, 4, 5, 6. Again, pi over 2 is the same thing as 90 degrees, so it's nothing changed. Yep, Grace, that's correct. You should use this one. So sine pi over 2 minus u is the same thing as cosine u. And this is cosine u, not cosine x, not cosine theta or cosine anything. So if you put cosine x or cosine something else, they will mark you wrong. So this is cosine u in this case. So make sure you, because you use u here, then you have to use u on that side. So that is usually using Pythagorean, not Pythagorean. You use the core function, they call it identity. Okay. So next 25. Yeah, this one is tough. All right. So this is again, pay attention. This is tough. 4 over secant x plus 1 minus 4 over secant x minus 1. Now, if I change the secant x to become just x, this will become 4 over x plus 1 minus 4 over x minus 1. Do you guys know how to add and subtract this kind of fraction? I'm just asking, Because if you doesn't know how to add and subtract this kind of fraction, then you cannot, this one, forget about it. So does anyone here know how to add and subtract fractions? First thing, when you add subtract fractions, if they are different denominator, what you need to find? When you add and subtract, if they are different denominator, what do you need to find? And this is all coming up in your test, actually, in my finals. Yep, you have to make them the same denominator by finding the LCD here. What is the LCD in this case? Grace, Ryan, Parker, what's the LCD in this case? LCD? Hello? They are not the same term. What happens if I give you 1/5 minus 1/4? What is the LCD here? Yep, Grace, that's correct. So you just take 5 times 4, right? Which is 20, right? Because they are different. So this is the same thing. The LCD in this case is x plus 1 and what? X minus 1, right? And then what you do once you get this as 20, you multiply this by 4. And you multiply this by 5, right? Same thing over here. So the LCD is the same. You have to, your denominator is the same. So you have to multiply this by x minus 1. Same thing to the top. And this one, you have to multiply this with x plus 1. So now your denominator is the same as your LCD. And then your numerator, you have to distribute. So what you have in this case is 4x minus 4. Don't forget, this is a negative. So this negative will be distributed with a negative 4. So make sure this. So you get negative 4x minus 4. And then you notice that the top one, the 4x and the negative 4x can be canceled out. So what you left in this case is negative 8 over by your LCD, which is all this. So this is how we do this question. So what do you think about question number 25? You think it's the same type? The answer is yes. So what you need to do first in this case is to find your LCD. And what is your LCD in this case? Same thing here. You told me x plus 1 and x minus 1. So the LCD in this case will be secant x plus 1 and secant x minus 1. Very similar to what you just did over there. And what you need to do next here is this one, you have to multiply with secant x minus 1. So I'll multiply this with secant x minus 1. Same thing we just did here. This one we multiply with secant x plus 1. So this one also you have to multiply with secant x plus 1. And what happens in your denominator is the same as your LCD that I mentioned here. So this one is going to be the same as your LCD. And then for the top one, you just distribute the 4. And this one, you have to distribute the negative 4 because we have a negative here. So what you get when you distribute your 4, you will get 4 secant x minus 4. And when you distribute your negative 4 in here, you will get negative 4 secant x minus 4. And what happens to your 4 secant x? Cancel, like what we just did in your 4x here is cancel. And when you combine like term, this is negative 8 over by last time LCD, right? Remember you put LCD. But this LCD is special because this LCD, you can FOIL it out. Do you know what happens when you FOIL? This one last time you just leave it as x plus 1 and x minus because you need to FOIL it. This one you have to FOIL it out. What happens when you FOIL your LCD out? Anyone? Anyone? What happens when you forward your LCD? Where is secant x plus 1 times secant x minus 1? You will get secant square x minus 1. That is correct. Because secant x times secant x is secant square x. The middle term, when you forward the middle term, they cancel because one is positive secant x, one is a negative secant x. That's why they cancel each other up. This will get negative 1. But you can do something with this. Because you got the square, we can use the Pythagorean identity. And one of the Pythagorean identity that you learn has a secant square, and that is him. This is the Pythagorean identity that have a secant square. So the identity is 1 plus tangent square equals to secant square. So we can use that identity. 1 plus tangent square equals to secant square. But this denominator is secant square minus 1. Can you make this Pythagorean identity looks like secant square minus 1? We can. What we do is we just move this 1 over there. And when you move that 1 over there, the positive 1 here will become negative 1. So can someone tell me what is secant square x minus 1?
Tan squared.
This is tangent. So this is going to be negative 8 over by tangent square x. And because your tangent square is in your denominator, we can always flip him back up there. Do you know what happens when you flip a tangent, reciprocal it, put it up there? Tangent will become what? Because this is in the denominator, right? This is actually is negative.
Cosine?
Yes, this is negative 8 times 1 over tangent square x. And because of this 1 over, it will become cotangent square x. So your answer in this case is negative 8 cotangent square x. And yes, this question will be coming out in your final, something like this, where I won't call you I won't call you to do this. I will call you to prove. I want you to prove 4 over secant x plus 1 minus 4 secant x minus 1 equals to negative 8 cotangent square x. And this is how you prove it. In the finals, usually I want you to prove things like that. Questions so far? Grace, are you all right? Anyone have any questions for me on this 3-1 before I continue with 3-2? I want you guys to try to do number 26. This is also a little bit tough. Can I, Grace, you guys got a picture of 25? Okay, I'm gonna 26. I can give you the answer, but you have to what do you call that? You have to figure out on your own. Get the screenshot. Yep. I want you to prove. Let me see what is the answer here first before I say. For a minute, I'm doing the I want you to prove this cosine x over by 1 plus sine x plus 1 plus sine x over by cosine x. And this is equals to 2 secant x. Yeah, this is your answer. Yes, this answer is 2 secant x. So this is actually is what you will do in 7.2 in my test. And this worth around like 4 or 5 points. So again, when you prove identity, you have to tell me, do you start from the left-hand side or do you start from the right-hand side? So left-hand side means this side. So you're proving left to right or you're proving right to left. Usually we pick the most complicated side. So we will start on the left-hand side. So if you take geometry class in your high school, this is what you're going to do. So now we're going to prove this to make it as 2 secant x. So does anyone here know what will be your first step to do here? First step. Same thing like 25. How do you add fractions or subtract fractions? What you need to find first? LCD, yes. And what is your LCD in this case? Again, there are 2 different denominators. You just multiply them. So your LCD in this case is cosine x, 1 plus sine x. All right, this is how I'm going to help you here. The rest, I want you to try to figure it out what to do. You guys have the input for me now. Anyone? Your input. You do not need to do the work. I'll do the work. I just write. You just need to talk to me. You can unmute yourself. Talk to me. Talk to me is better because it's quicker. So unmute yourself. Except for Ryan, you don't have a mic. You might have to type because typing is going to be a lot of typing. So just unmute yourself and tell me what you need to do next. Yes, the first thing is you have to find your LCD. That's your first step. Anyone
and you
know
multiply the cos x on top by the 1 plus sine x and then vice versa.
Okay, good. That is your second step. So you have to make your denominator the same. So you have to multiply the first one by cos sine x and this by 1 plus sine x. Very good. Same thing happens now. When you multiply the top one here by 1 plus sine x, you have to FOIL it out. That is the second step. This is step number 2, the orange one. All right, step number 3, gray. What are you going to do next? Very similar to number 25 that you did. What happens to your denominator? Remember on 25 what we did in denominator? Yep, Grace, Ryan, Parker. You FOIL the top. Yes, the top one you FOIL it. So let's do the top one. So the top one you have cosine x times cosine x. You get cosine square x plus, because it's a plus. Yes, you have to FOIL this one up. I want you guys to go ahead and FOIL 1 plus sine x times 1 plus sine x out. And tell me what you get. I would recommend you to talk, unmute yourself if you have mic. And if you get it wrong, don't worry about that because this is where, again, this kind of questions is coming out in your finals. So you have to tell me what side you start from. First step is LCD. Second step is to make them the same. Third step is FOILing this out. Grace, what you get when you FOIL this one out? Or Parker, or Ryan? Yep, is 1 plus 2 sine x plus sine square x. Yep, right. Grace, you also get the same thing. You just rearrange it, which is fine. What happens to your LCD? Now, what happens to the denominator is you have to put your LCD here. which is cosine x, 1 plus sine x. Now you notice that I did not FOIL or distribute your LCD. The reason why I don't FOIL or distribute the LCD here is because hopefully we can cancel something on top. Can you cancel like this? Oh, cosine x and cosine x. Oh, 1. Oh, sine x. Can you do this? Can you do like what I just did in here? Yes or no?
No.
No, because they are all adding and subtracting on top. You cannot cancel. This one you can, because I mean, they have to be multiplying. So what do you need to do? This is step 3 in gray. Now I'm going to do step 4 in red. Anyone know what to do here? That's the reason why I told you this is all you have to think outside the box. I cannot teach you. You have to see it. Anyone know what to do? Don't forget, your goal here is to get 2 secant x. This is your answer. Anyone? Check identities. Very good, Ryan. Which identity you should check? Very good. Which identity should we check? Yes, if you're stuck, check your identities. That's correct. Which one? We got quite a few identities. Oh yeah, very good. Pythagorean. Yes. Grace, cosine square plus sine square equals to 1. So which one here do we use the Pythagorean identity here? You can use this and this, because this is cosine square plus sine square x. So this will give me 1. So now you can combine all these terms. Can someone tell me what happens when you combine all these terms? What you get?
2 plus 2 sine x.
2 plus 2 sine x, yes. Now what can you do with 2 plus 2 sine x? What can we do with this? You're very close. So this is 1 and this is 1. That's why 1 plus 1 gives you 2. Anyone know what to do with this 2 plus 2 sine x? Parker, Ryan, Grace? Just a little bit. Once I tell you what's going on, then you will see the picture. We cannot cancel it, again, because we have a plus here. We cannot cancel it. We cannot cancel anything yet. Anyone? What are they in common between 2 plus 2 sine x? Can we factor something out? What can we factor out here? Yeah, not 2 negatives. We just factor the 2 out because they are common, because they have 2. So once you factor the 2 out, what you get? Yes, you get 1 plus sine x. And what happens to your denominator? Now, can we cancel?
Yes.
Yes. So I want to tell you that because once you factor things out, then you can cancel it. So what you get in this case is 2 over cosine x. But I want 2 secant x. How do I change this to that? This is easy, you should know. Must be, yep, reciprocal. So this is 1 over, this is actually is 1 over cosine. So that is the same thing as secant x. Yep. So this is how you get this answer. This is how you get to your right hand side. So this is what you will do in my 7.2 in the finals. So make sure you guys know that this is not easy. This is tough. And this is something that I cannot teach you, but I can help you with. And then in the test, you have to do it yourself. And another meaning is if you look at your 7.2 homework, they're all fill in the blanks here, right? You see all of them are fill in the blanks. In your test, there's no fill in the blanks here. You have to figure out all on your own here. So that's the reason why that is very tough for you guys to, so you have to practice, not tough, you have to practice this. So these all fill in the blanks for 7.2. So we can try to do like question number, anyone have questions on 7.2 here? Anyone have any question on 7.2? Otherwise, I give you more. Then you have to figure out yourself. Anyone have any questions on 7.2? 14? Okay. I just want to change all my theta to x because it's easy. So you guys get used to it. 14. This is 7.2. 7 cosine x cotangent x over by 1 minus sine x minus 7 equals to, I'll do that later on, Grace, 7 cosecant x. Yes, you can change all your theta to x or y or whatever, a, b, c, whatever you want, but I prefer. All right. So now, one thing I want to point out about proving identities here, this is very important, is a lot of students, oh, this 7, I'm going to move it to that side, plus 7. Oh, this 1 minus sine x, I'm going to multiply this with 1 minus sine x. No, I multiply both sides, right? This is gone. And then I will just FOIL this one out. Oh, I FOIL this one. 7 cosecant x times 1 is 7 cosecant x. 7 cosecant x times negative sine x is negative 7 because cosecant x and sine x is 1. So when you multiply it reciprocal, sine times cosecant is 1. And then 7 times 1 is 7. And then minus 7 sine x. So this 7 will cancel out. Then you begin to do like all this works. And then finally, and then you factor the 7 out. So I got cosecant x minus sine x. And then you try to figure out, I mean, after you figure out, you know, you do, and you end up with 7 cosine x cotangent x. Like the same thing you just did here. Do you know how much point do you get when you do this? I mean, everything you did is correct. I mean, everything down here, everything, this one, what you do here is you change it to become 1 over sine x, and then you find the LCD and all that, and then you get, slowly you will get into the 7 cosine x cotangent x. Do you know how many points you get in your test? If you do it like this, which is, I need to say it's wrong, it's correct. 0. Yep. Why? It's because you are not proving, you are solving here. So this is something that I want to point out to you guys and those who watch the Zoom video in YouTube. This, once I want you to prove, you cannot move things around like this, or move the 7 around, or multiply. You're solving it. So make sure when I want you to prove, you prove either from the right or the left-hand side, but not solving like add 3 divided by 5 and all these things. So if you did that, you get a big fat 0. I do not even look at it. I'll give you a big fat 0. Okay. So in the finals, do not do this. Otherwise, you get a 0. It's very easy for me too. So never, 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 never do this. So now, what do we do here is, I'm gonna go back. Oh my goodness. All right, so what do you do? Anyone? Let me erase all this. Let me restart the whole thing. So anyone know what to do here? Seven cosine x cotangent x over by 1 minus sine x minus 7 equals to 7 cosecant x. So first thing, can you tell me, do you start from the left-hand side or the right-hand side? Pick the complicated side. Which one is complicated, left or right? So which side do you start at? From the left, right? Because this is complicated. So you're going to start with this side. Do we have fractions here? We have fractions, right? So this fraction 7 is over 1. Like last time, like question 26 and 25 we did previously, what you do when you add or subtract fractions, what's the first thing you need to do? You have to find the, so every time when you see fraction adding and subtracting fractions, find the LCD, yes. And what is the LCD in this case? Yep, so what they do here is they find the LCD. And what's the LCD in this case? 1 minus sine x and 1. So the LCD is 1 minus sine x, right? Like 1 over 5 and 7. Can you tell me what is the LCD in this case? Because this is over 1, so the LCD in this case is 5. So the same thing happens here because you have this, the LCD is 1 minus sine x. And then what's the second step? Like what Parker told me, try to make your denominator as your LCD 1 minus sine x. Do we need to multiply anything on the first term? No, we do not need to because it's already have 1 minus sine x. This one you have to multiply by what? 1 minus sine x. So that's the reason why this 7 parentheses, this is where you're gonna do 1 minus sine theta. Oh, where's my friend theta? Okay, I just put x, but they will mark you wrong, so make sure you put theta. The theta is under symbol here, okay? So I don't have, let's get, I don't have time to put all this data in there. Okay, so yep. So anyone know what's next to do? So I would distribute this 7 in there, right? Negative 7 in there. So what happens when I distribute this negative 7 in there? Do you get something like what you see over here? Negative 7 plus 7 sine theta. So this is what you have in this big icky parenthesis. Do you guys know what they did over here? Do you guys know what they did over here? Anyone? Yes. They changed the cotangent to become cosine over sine. So what you get here is, I'm going to erase, I'm going to just put a quick X on it. So this will be replaced by cosine over sine. So this will be cosine. I'm going to put X because I don't have time for theta, but make sure you put theta because if you put X, they will mark you wrong. Okay, I just put X in there, but it's theta. All right. Now, if you look carefully, what they did here is they did this. Do you see this one on the side? So can someone tell me why they do that? Anyone? Why they put that thing over there? Why they put this over here? Anyone? This is all important. Yes, you're going to do the same thing. This is very difficult. I didn't say this is easy. Grace, Ryan, Parker. Why I put sine x here? Yes, Grace is correct. To cancel, so that this, because we have the sine x here, and we do not like fraction. Usually when you see fraction over fraction, you get headache. So you only get fraction. So we multiply this by sine x, so you cancel. So what you do here is you distribute this sine x. So when you distribute this to the top, you have to distribute 3 times. And the first term, the sine x will cancel. So what you get here is 7 cosine square x. 7 sine x, because 7 times sine x. This one will be sine square x. And then because this you multiply, because when you do fractions, you multiply them straightforward. So you got sine x, 1 minus sine x. So this is what you have for this question here. So that's why they got, oh, they even do more after that. So this one you will have, this one, if you look carefully here, this one looks like your denominator. So you should have sine theta or sine x. I use sine x, but it's the same as sine theta. And what do we do next here? Forget about that, because in the task, as I told you, it's not fill in the blank. You have to do this. Can someone tell me what to do next here? Ryan, Parker, Grace? This is very tough. It's like if it's level 1, 2, 3, 4, 5, this is level 4. Yes, because this and this has the square. And do you remember when you have a square, we can use your Pythagorean, right? But unfortunately, Pythagorean says sine square plus cosine square equals to 1. But we have 7 cosine square plus 7 sine square. Can I multiply all this by 7 using a Pythagorean identity? Yes. So what you get? 7 cosine square, 7 sine square, and you get equals to what? 7. So can someone tell me what you will get when this 2 orange circle one when you use Pythagorean identity on it? You will get what? 7. Yeah, you will get 7. And then you still have 7 sine x over by the same thing. Sine x, 1 minus sine x. Do you still remember last time what do we do with 7 minus sine x? Remember last question? Very end before we cancel, what do we do with that 2? Remember? This is the same thing. What are you going to do with this 7? Factor it out. Yes. So you find out that they're very similar when you do this. Yes, I can tell you that when you guys got a fraction piece like this, you have to do the LCD, you have to do this, and then you figure out there's a Pythagorean, and then after that you factor out the 7. That's correct. And then what happens when you factor out the 7 is you got 1 minus sine x here, right? And then you got the sine x, 1 minus sine x. And what happens to the 1 minus sine x is the 1 minus sine x? You can cancel it. So what you left is 7 over sine x. But my question is 7 over cosecant x, which is a little bit off, you know. Last time, what we do with this 1 over sine x? We use the reciprocal, right? So that's why you get the 7 cosecant x in this case. So this is what you did in number 14. So mostly when you do here, you figure out that they are the same. See, you got the 7 minus 7 sine x. And this is still going to have a sine x in this case. And then what happened is that you factor the 7 out. And when you factor the 7 out, you notice that the sine x will cancel out. You will get 7 over sine x. So this will be 7 over sine x. And then after that, you get a cosecant x. Again, change all the x and become theta here. And that's how you do this. Okay. Number 6. Number 6, you have to use the identity. This one is no proving. It's identity again. So which identity you have for question number 6? Grace, you should know this. Which identity we use for number 6? Reciprocal, quotient, Pythagorean, cofunction, even odd. Which one? Make this bigger so you guys can see. Yes, secant is even odd here, so it's right here because your angle is negative. So it's not negative because if you look at this, there's no negative here. Secant minus negative u is the same thing as what? Just secant u. Okay, no negative because it's an even function. Even function, you don't put a negative in front. Okay, all right, 16. Okay. This is all even too. Cosecant even odd function identity. Cosecant negative x, secant negative x equals to negative cotangent x. All right. So can someone tell me what can we do with this? It's going to be a left-hand side because this is more complicated. So can someone tell me what identity we have to use for cosecant negative x? Reciprocal, quotient, Pythagorean, cofunction, even odd. Cosecant negative x, which one should we use? We did secant, right? Just now, Grace asked me question number 6. So what is secant negative x is? Secant negative x is secant x, right? So what is the cosecant negative x? Cosecant negative x, because it's
Negative
a
cosecant.
This is negative cosecant x. Yes. Anyone know how to change this to that? To negative cotangent x? What you do next? This is level 2. This is easy compared to what we did just now. Some students, the easy one doesn't get it. The hard one, they know how to do it. What we do with this fellow, anyone tell me? And this one. Any identities you can use? Any identities? Which one should we use? There are identities. What is called negative cosecant x is? We will use the reciprocal identity. So cosecant x is actually is what? Negative 1 over sine. And secant is 1 over cosine. Do you guys know what to do with fraction over fraction? This is the same thing as what? This, the division, I change it to become what? Multiplication. Then what you do with this bottom part, you flip it. What do you get next? Multiply, it's no like terms, you cannot cancel. So multiply them straight across, you get what? Negative cosine x over sine x. And cosine over sine is cotangent. And this is how we do this part. Number 16. So when you do this, yep, you got a -1 over sine over here. This will be 1 over what? Cosine x. And then this one, negative sine x on the bottom. So this will become cosine x on top. Again, class, as I told you in the test, you won't get fill in the blank like this. You will get something like what I just showed to you. You guys doing all right here? Before I continue with 7.3. Tough? Yes. Practice a lot. And when you practice, please don't practice this way because this is not the correct way to practice. When you practice, take out your textbook. Okay, go to 7.2 at the end of 7.2. At the end of 7.2. Come on, it's slow. I don't want chapter 2. At the end of 7.2, there is a lot of 7.2. Oh my God. Exercise. Go to 7.2 exercise. And this is what you do. Yes. There are a lot of them. Just start with this one. This is easy, 9. You look at the answer. Answer will vary. Answer will vary. So that's why there's no answer. You need to check for answer because the answer is given to you. So try to do this. This is the one that you will get in my finals. This is easy. Level 1, level 2. This is like level 2, level 3. And then the more down you go, you will see like square roots like this. This will become level 4, level 5. Yes. And then you will maybe get something like this in my test. Remember in my midterm, I put an X next to it, means that there is an error. So you have to find the error. And then after that, you have to correct it. So so you might get something like this in your finals too, that you get an X next to it, means that you get a wrong one. You have to correct it. You have to find where's the wrong piece. And then after that, you have to figure out where and then after that, you have to redo the whole thing again, correct it. Questions. So this is something I will recommend you to practice. There's tons of it here. And the more down you push, the more difficult it gets. This is like level 6, level 7. This is super tough. So do not do this. This is for super, super tough. Okay, when you have the tangent and the arcsine, forget about it. Okay, try to do something that is up to 54. This is a good practice. You guys got me here? So you got nothing to do. What level of test, Grace, you will get like level 2, level 3 first, and then after that you will get a level 3, level 4. Remember that 25, 26, that one that you do with that factor the 7 out and so on, that will be coming up. So make sure that's why I practice. You won't get something with the square root. You won't get something with the inverse, like what you see here, the cosine and the inverse of sine. You won't get that. Those are very tough. This one, pretty tough here. I mean, you can do it. It's just I do not want you to do it, but try to do the rest of it. Okay, up to 54. I will recommend you to go up to 54. Questions? All right. I won't give. Then we talk about 7.3. Yes, this is something I want to point out. Now, what's the difference between 7.2 and 7.3? 7.2 is where you do proving identity or establish identity. So when you read my or verify, so when you do my finals, read the question carefully. If I want you to verify the identity, that means that I want you to prove. Okay, so that means you cannot solve it. But when you do 7.3, look at the exercise. Yes, this time I don't want you to verify it. I want you to solve it. Okay, you see the solving piece here. Now you're gonna solve this. So there are two different things. So read the question really carefully in the finals. Okay. Now, when you solve a trigonometric equations, it's like solving equations. So like you try to make factoring, user identity, isolate the trigonometric function. What's mean by isolate the trigonometric function is like this. cosine x minus 1/2 is 0. So when I want you to solve, not to prove, you are solving for x here. So what you do is you move the negative 1/2 over. So you get cosine x is 1/2. And now you have to move the cosine over. Do you remember what happens when you move your cosine over? It will become the arc, the inverse of cosine. Now you have to tell me what angle will give me cosine is 1/2. Anyone remember? What angle for cosine is 1/2? Your answer is either 30 degrees, 45 degrees, or 60 degrees. But usually we do not use degree in here. We use radian. Pi over 6, pi over 4, pi over 3. Anyone remember cosine what give us 1/2? Cosine 30, cosine 45, or cosine 60? Cosine 60? That is correct. So your answer in this case is pi over 3. Now, this is correct. Yep, this is correct. But unfortunately, this is the word for unfortunately, when you guys do the solving piece, you have to figure out what is the domain given to us. If your domain goes from 0 to 2 pi, then you will have a second answer. Let me repeat. If your domain is 0 to 2 pi, you get second answer. And how do you figure out the second answer? Remember chapter 6.3? All students take calculus. Can you tell me cosine is positive in quadrant what and quadrant what? Quadrant 1 is positive for cosine. What? Quadrant 4, you are correct. So can someone tell me what is pi over 3 in quadrant 4? Angles, you should know. 60 degrees. What is 60 degrees in quadrant 4? Oh, by the way, yeah, oh, good. Ryan, 5 pi over 3. Yes, this is correct. So this is your correct answer. So if the domain is 0 to 2 pi, you get pi over 3 and 5 pi over 1 and 4. But what happens if your domain is all real numbers? That means it goes loop and loop and loop and loop and loop. So your answer in this case is going to be the same as pi over 3 and 5 pi over 3, but you're going to add 2n pi. What is this 2n pi? This 2n pi is talking about one circle. It's because 2 pi is one circle. And when you involve the n means you can go 1 circle, 2 circle, 3 circle, 4 circle, and you can also go counterclockwise, negative 1. So you can go clockwise and counterclockwise for positive and negative. So that's why when you have all real numbers, you just need to add 2n pi in this case. But if a question wants you from 0 to 2 pi, then you get 2 answers. Okay. Don't forget cosine, secant, which is the same thing as cosine, which is reverse, sine and cosecant. You will add 2n pi if they want all real numbers because they all go like infinity. Because for sine, cosine, secant, and cosecant, your period is 2 pi. So that's the reason why that you add 2n pi. However, if this is a tangent or cotangent, then you do not add 2n pi, you just add n pi. The reason why you add n pi is because your period for cotangent and tangent is just pi. You with me here? You with me? Questions? This is how you solve this. So this is cosine x minus 1/2, right? So now I'm going to change this to cosine 2x minus 1/2. Now this one is even more difficult. The reason why it's more difficult now is because this angle is called a multiple angle. Last time is x, now it's 2x. If you have multiple angles, last time when you have x, how many answers do we have? We got the pi over 3 and the 5 pi over 3, right? You got 2 answers, right? If you have 2x, you will have 4 answers. So if you have 2x, you get 4 answers. If you have 3x, you will get 6. 4x, you will get 8 answers. So the more x you have, the more multiples you have, then you have to keep on multiplying by 2. So how do we solve this kind of multiple answer? Same thing as what you did last time. You move the half over, you move the cosine over. So 2x in this case is the inverse cosine of 1/2. And as usual, this is what we just did just now. You get the pi over 3 and 5 pi over 3. But this is equal to not x, to 2x. Now what you need to do is you have to divide all this by 2. Now, do you know what happens when you have a 360 degrees? Do you know what happens when you divide by 2? This 360 degree become 180 degrees. But my domain in this case is from 0 to 2 pi. And when it goes to 0 to 2 pi, you have to figure out the other one. So this will give me 2 answers, which is these 2 answers. And then the other one will also give me the other 2 answers. So how do I find the other 2 answers? You add 2 pi to this. So when you have a 5 pi over 3 plus 2 pi, you will get 7 pi over 3. And then 5 pi over 3 plus 2 pi, which is 11 pi over 3. And this, you have to divide all by 2. So your answer in this case, which will be 4 answers, will be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So this is when you have a domain from 0 to 2 pi. And don't forget, 11 pi over 6 is still in 2 pi. But what happens if you have all real numbers? All real numbers last time, we will get 2x equals to pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. This is what you have last time. So what you do here is you just need to divide everything here by 2 and you will get your answer. Pi over 6 is no longer 2n pi because the 2 will cancel out. So this will become n pi. So what happens, and this is pi over 6 plus n pi. So what happens when you have an all real solution? You still use back the same thing, but your 2n pi now will be divided by 2. So that's why you only have 2 type of answers here. Because when you add, the reason why is because when you have a pi over 6, when you add pi, it will reflect back over here. And when you add pi, you reflect back over here. So this will take care of that. And then same thing happens to the 5 pi over 6. 5 pi over 6 is over here. But when you add pi, you go back to quadrant 4. And then when you go add pi, you go back to quadrant 2. So this will take care of quadrant 1 and 3. And this will take care of 2 and 4. So that's the reason why that when you have an all real number, if a domain is all real numbers, you do not need to do like what we did here. We just continue doing the x one, and then you just divide by 2. If this is 3x, you just divide this all by 3. Same thing here. But unfortunately, if this is 3x, you have to add 2 more answers here and divide by 3, because you should have 6 answers when you have 3x. You guys with me here? Is this tough? Kind of tough. As I told you, this is something that you need to watch out, and it's not easy. So I would recommend that when you read the question, so if this question says solve equation in rate, oh, sorry, let me look at your homework first. Where's your homework? 7, 1, 2, 3. So if a question just asks you solve the equation, solve the equation, that means the question wants you in all real numbers. Okay, so if a question wants you to say solve the equations, then the question wants in all real numbers. If a question says find a solution in an interval from 0 to 2 pi, then you need to do this. You guys with me here? Questions that you guys have? Questions? And the last thing I want to point out here is, do you need to check your answers when you got your answers? You need to check it. If you have time, you can check it. You can just plug this number back into your x, and you should get 0. You should plug every single one of these. If you have 4 answers, plug 4. So checking in this case is optional, like solving for x, checking is optional. However, this is one thing that you need to pay attention here, is you can square the equation both sides. That means sometimes like here, you can square both sides. The reason why you square both sides is because you can use Pythagorean identity, cosine squared, cosine squared. However, if you square, you have to check for extraneous solution. So what do I mean here is, if this is one way to do it, but if you want to square both sides of the equation, you can do it. It's not wrong. You can do it. You get your answer, then your answer checking is required. The reason why is because some of the answer might not work, because once you square something, square both sides on somewhere, it might not work. So that's the reason why that this squaring the both sides of the equation is always plan Z. That means that don't use this. Do not use squaring the both sides. The reason why I don't want you to use the reason why I do not want you to do this is because you have to check every single one. So if you got 10 answers, you have to check all the 10 answers you have. So please try to avoid squaring both sides here. That's what I'm talking about. Okay. Does anyone have any questions for me? And every answers that we're asking for here, they're all in terms of radian. Same thing in your test. So if you give it to me in degrees, I will take points off. So make sure everything here is in radian form. All right, anyone have any questions? So your next homework is going to be 7.3 and 7.4. This is what we're talking about here is 7.3 when you have to solve this equation. Then 7.4 is you have to add and subtract matter. That's 3 more identities you have there. So we'll talk more about this next week. But make sure you guys start working ahead. As I told you, chapter 7 is a killing chapter. Means that it's very difficult. I will find some videos about this. I think I can find this easily on YouTube. So make sure you guys watch these videos. Okay. So I'm going to stop sharing here. Anyone have any questions for me before I let you guys go? I'm going to stop recording now.